Okay, the locus that we're given at the start can be written in this form. Z minus hopefully we can recognize that as being a circle. Center minus 12 minus 5 with a radius of 13. Okay, so we know the equation of that circle, therefore in Cartesian form is going to be x plus 12 plus y plus 5 equals 13 squared, 169. Okay, now we know that x equals r cos theta, and we know that y equals r sine theta, and we're trying to show that is true. Okay, so plug those into the line above, so we're going to get r cos theta plus 12 squared, r sine theta 169. Expand it out, we're going to get r squared cos squared plus r squared sine squared. Put those together because cos squared plus sine squared will be 1. I get 12 and then double it, so 24 r cos theta, 10 r sine theta. 12 squared and 5 squared is 169. Okay, so I can get rid of the 169s. Over here I've got r squared cos squared plus r squared sine squared, so it's just r squared. Take a factor of r out. Since r does not equal 0, we've got r plus 24 cos theta. We know what we're aiming for, so 10 sine theta equals 0. Move it across, r equals, you could almost jump to the answer now, r equals minus 2 lots of okay, so again make a note, you're finished, proved, or QED or something similar. Now it says show on an Argand diagram the overlap between those two. Okay, so I know the centre of the circle is minus 12 minus 5, and I know it's got a radius of 13. So let's do it here. Minus 12 minus 13. Now it doesn't have to be to scale, but I've got to be honest, I do like some sort of scale. So we're going from minus 12, let's do it. 2, 4, 6, 8, 10, 12, 2, 4. Let's do it, sorry. 3, 6, 9, 12, go up in threes. And 5 would be there roughly. As I said, this does not need to be to scale. So this is minus 12, but do mark on the points. Minus 5. Now, I know it goes through the origin because this distance is 13. Okay, so it's 12 squared, 5 squared. I know it goes through the origin. So therefore I know it will go through minus 24. Over here somewhere. Try and keep sense of scale. By symmetry. And because it goes through there, it will go through minus 10 as well. Now, I'll probably should, let me try and get a compass. Let me pause it. Okay, so I've used a compass to get a fairly accurate diagram. And then you're also told the argument of z is between minus pi and minus 3 pi by 4. So the argument of z from 0, because it just says z, minus pi will be this way, minus 3 pi by 4 would be round here. So we know it's going to go at 45 degrees down here. So we know the angle lies between these two, and it lies within the circle. So the area or the region we're looking for is this. Okay. Now you don't have to do it quite as neat as that, but please make sure it's reasonably accurate, and make sure you got a compass, or do the circle first and do the axes on afterwards, just something to make it look a little bit neater. Now we've got to find the area of the region defined by A. So the area equals a half integral of r squared d theta. And we know theta goes from minus 3 pi by 4 to minus pi. I'll put that in a minute. So it equals a half integral of, we know r is from the line above, so I'm going to square it. So I get 4, squaring that, and then I get 12 cos theta, 5 sine theta squared d theta. So it equals half of 4 is 2, 144 cos squared theta, 25 sine squared theta, 5 times 12 doubled, 120, no space, sorry, sine theta cos theta d theta. Okay, make sure you lay yours out slightly better than mine. Okay, so now we've got to use the double angle formulas. So it's 2 times cos squared. We're going to use the 2 cos squared minus 1 equals cos 2 theta. So we end up with 72 lots of 1 plus cos 2 theta. That space again. And then we're going to, similarly for this one here, we're going to use the 1 minus 2 sine squared equals cos 2 theta. So we get 25 over 2 times 1 minus cos 2 theta. And this one, sine 2 theta, is 2 sine theta cos theta. So here we've got plus 60 sine 2 theta d theta. The reason why we're transferring it from cos squares into cos doubles and sine doubles is because integrating these is straightforward. Okay, so we integrate those. Let's move down a bit. I'm getting a bit cramped here, aren't I? Let's just go down here. So this equals 2, yeah, probably go straight into a 2 bracket 72 theta plus sine 2 theta over 2, 25 over 2 theta minus sine 2 theta, still out of space, 2 plus 60 cos 2 theta over 2, and because cos integral sine is minus cos, I need to change that to a minus, and I'm going to put the limits in minus 3 pi by 4 to minus pi. Alright, and after all that, you get doesn't want it accurately, so you could just plug it straight in now. You get you can do it accurately, you end up with 169 pi by 4 plus 239 over 2, which equals 252 square units, where the units are.